Hello children, today in Algebra we are going to study the chapter Sets. What is a set? A set is a group or collection of various objects which can be counted or written down. A set is well defined. Let us understand the meaning of this word well defined. Observe this. Number of alphabets in English, multiples of 4, days of the week, all these can be counted and written down. But what about tall students in the class, rich men in the world, strong forts of Maharashtra? Tall, rich, strong is not something that you can count. So all these things will not be included in a well-defined set. Okay, so these tall, rich, strong, beautiful, ugly, or whichever such adjectives will not be included in a set. So then what is a set? A set is a well-defined collection of various objects. Now there are certain rules when you write a set. Let us see what those rules are. A capital letter is used to denote a set. Just like everything has a name, we will be using capital letters to name a set. Brace brackets are used to list out these. Okay. Each component is known as an element or a member. And commas are used to separate the elements. We will be learning how to do this when we go further. And the last part, a data which repeats itself is written down only once. So when we write a set, these are the 5 things that you will remember. Look at these examples now. The first one is a set of vowels. We have to form a set out of this. So we use a capital letter to denote it. It can be any capital letter. Let us use T. Okay. So we write T is equal to, and then we use the brace brackets. What is it? It's a set of vowels. So the vowels that we have are A, E, I, O, U. Did you observe one thing? That I have used commas to separate these elements. A, E, I, O, U are known as the elements or the members of set T. So T is equal to A, E, I, O, U. Now let us look at the next set. A set having multiples of 5. Multiples, that is the tables of 5. Let us use another capital letter. And now I begin with 5, 10, 15, 20. Now you'll realize one thing, that these tables go on and on and on. So I will put a comma and a dot, dot, dot. That's it. So it shows me that the table isn't ending. This set will continue. The elements will continue. Let us look at the last one. A set of letters in the word common. So again, let us take any other capital letter. This is a very important part. A data which repeats itself is written only once. What do you realize in this word common? O has been repeated and M has been repeated. Okay. So we will take these alphabets only once. So C, O, M. M is repeated, O is repeated, and N. And then we close it with a brace bracket. So this is how a set is written down. Hello children. Today we will learn what are the methods of writing a set. There are 2 ways in which a set can be written. The first is the listing or the roster method, and the second is the rule or the set builder method. Let us now learn the listing method. As the name suggests, listing method means a method where you list out or simply write down the elements in that set. Let us see the first example. A set of multiples of 3. We have seen a similar example before this. So we begin with a capital letter. Multiples of 3 begin with 3, 6, 9, 12, it goes on, so comma, dot, 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 and then we close with a brace bracket. A set of vowels in the word medal. So there are two vowels here, E and A. So we write it as E, comma, A. The next is a set of squares less than 25. Now here there are two things here. A set of squares, so we need squares, but squares which are less than 25. So there is a condition given to you. So let us begin with writing the answer. Which are the squares? 1, 4, 9, 16, less than 25. So we cannot include 25 here. So the set is complete. The next one, a set of integers between 7 and 8. 7 is an integer, 8 is also an integer. So can there be an integer between 7 and 8? No, there is no integer between 7 and 8. So what happens to such a set? There is no integer here, so I do not write anything here. Okay, we call it as a null set. Let us take the next example. A set of multiples of 2 which are more than 12 and less than 22. So again there is a condition here, more than 12 and less than 22. Multiples of 2 which are more than 12. So we begin with 14, 16, 18, 20. The next condition is less than 22. So the set is over here itself. Okay, the next is a set of the even prime numbers. Which are the prime numbers? This is my rough work here. 2, 3, 5, 7, okay, 11. What is the second condition? Even prime numbers. Amongst these, which are the even prime numbers? Only 2. That's it. So this is the method in which you will list out the set. Now let us learn about the rule method. First let us learn how to read it. This is the set given to us. A is a set of all x such that x is the shortest month. We will read it as A is a set of all x such that x is the shortest month. Now we will be solving the remaining examples in the same manner. In this example, let us observe the elements here. 0, 1, 2, 3, comma, dot, dot, dot. These are whole numbers. Okay, so we will be writing this as B is a set of all A such that A is an element of whole numbers. Is an element of. So this symbol stands for element of or member of. So B is a set of all A such that A is an element of whole numbers. In this set, if you observe these elements, these are multiples of 10. Okay, so it is 10 into 1, 2, 3, 4, 5. Correct? So this A will be 1, 2, 3, 4, 5. And what are these 1, 2, 3, 4, 5? These are either whole numbers or they are natural numbers. We will use natural numbers this time. Again, there is a criteria. These are natural numbers which are less than 6 because although the table continues, we are using only numbers up to 5 so that we get 50. So I will write this as C is a set of all B such that B, what is B? B is a multiple of 10, okay, 10A. Now what is this A? This is the A. So what is A? 1, 2, 3, 4, 5, which is a natural number. So A is an element of n. There's one more condition, that A is less than 6. Now what will happen if we consider A as a whole number? Whole numbers begin from 0. But here the whole number we have used here is 1. So we will have this condition. Okay, so this 1, 2, 3, 4, 5 is greater than 0 and less than 6. So A is greater than 0 and less than 6. So the condition will change because you're using a different set of numbers in both the cases. Now 15, 18, 21, 24, these are multiples of 3, correct? So earlier we had 10x, so here we have 3x. So what is that x? 3 5s are 15, 3 6s are 18, 3 7s are 21 and 3 8s are 24. So this is the x part. And what is the x part belong to? It belongs to natural numbers. Okay. Are these natural numbers right from 1, 1, 2, 3, 4, 5, 6? No. They have a limit here and they have a limit here. So these are natural numbers. X is greater than what? 4 and less than 9. So again this remains the same. D is a set of all x such that x equal to 3x, or we can take it as 3a because we have used x over here. Okay, what else? A is a natural number, or A belongs to n. And what is the last condition? A is greater than 4 and less than 9. In this set, you realize 2, 1, 0, negative 1, negative 2, negative 3, comma, dot, dot, dot. These are integers, okay? But these integers are continuous on the side, whereas here there is a limit. So let us see how to write this. So E is a set of all m such that m belongs to which set of numbers is this? Integers. Okay, again we have to see the limit. These integers are less than 3. So m is less than 3. Observe these numbers here, 1, 4, 9, 16. These are squares. So it is a square of a number. So let me write it as a square, which is 1, 4, 9, 16. From this, let us find A. A is 1, 2, 3, 4. Okay, 1 square is 1, 2 square 4, and so on. So now, when we write this set, it will be F is a set of all Q such that Q is what? Is a square of A. Okay. What is the set of A? These belong to natural numbers. So A is an element of natural numbers. Are these all natural numbers or are they continuing here? Yes, they are continuing. So there is no limit on this side. So the set is over. This is the set. Just like the previous sum, if you observe these numbers here, 8, 27, 64, 125, these are cubes. Okay, so y cube. Let me write it down. From this, let us get y. 8 is whose cube? 2. 2 cube is 8. 3 cube 27. 4 cube 64 and 5 cube 125. And what are these? Which group do they belong to? Natural numbers. You may also take it as whole numbers. These are natural numbers which are greater than 1 and less than 6. Okay, so G is a set of all P such that P is y cube. Y is an element of, let us take whole numbers this time. But what type of whole numbers? Where y is greater than 1 and less than 6. Last set here has a single element 7. Now 7 is an element of whole numbers, it is an element of natural numbers, it is an element of integers. So I can take any of these sets to represent 7. So let us begin. H is a set of all x such that x belongs to, say, integers. Okay, what is the limit now? This integer 7 is greater than 6 and less than 8. So this x is greater than 6 and less than 8. Even if I write this as an element of natural numbers, still there will be no difference. Okay, so we have learned how to write a set using the rule method or the set builder form.